Hey kids, it's Dr. Runs here, and we have a lesson for you on using the distributive property. This should be a skill that you have already learned, but if you didn't, I'm not going to judge you here. I'm just glad that you are listening so that you can figure it out so that we can build on that skill moving forward. This is also a very long lesson, so for the sake of your sanity and my being able to upload this in a timely manner, I'm going to talk a little bit faster. So I need for you, the listener, to please feel free to stop and replay and back up as often as you need in case things go a little bit too quickly, so that you understand this, because that's really the point of the videos, so that you can get another shot at learning this stuff from home. Okay, and as always, I do my best to give good videos to you guys that you can learn from and benefit from, but different math teachers might do a little bit different, and I've never claimed to be perfect, so it is what it is, and hopefully you benefit from it at home. Okay, I have some illustrations here for you at the start, and they're a little, I don't know, more difficult to, I guess, draw out. So I'm just going to go through this way and I'll guide you through what I have typed, because I think it will just go a little bit easier for us. So if I have 4 with a parentheses with a 6 in it, when those are pushed together with no sign in between, that implies multiplication. And we know that 4 6s means 4 times 6. It also means 4 groups of 6, or you could say 6 groups of 4 technically, but this means 4 groups of 6 somethings. So when I think groups of 6, I think of dice. So if I roll 4 dice and each of them have a 6, that would also represent this multiplication problem. Multiplication is also repeated addition of the same number. So each of this dice has a value of 6, and we're adding them all together. And of course we know 4 6s is 24. Hopefully that was simple for you. We're going to make it just a little bit more difficult. So similarly, if I have 5 and x together, that means 5 times x, whatever x is worth. We don't know. It's a mystery. And it's 5 groups of x. Again, whatever x is worth. It could be that you have these weird little square coins from another land, and you don't know where, you don't know what they are worth, but you have 5 of them, right? This would be like having 5 groups of this strange coin that you don't know what its value is. It would still be repeated addition, just like multiplication of 2 numbers. If you're multiplying a coefficient with its variable, that's the same as what it is. 5 added with itself, x added with itself 5 times. Or we can simply say 5x, which is where we started. That was pretty cyclical. We ended where we began. And here we have now an expression that involves parentheses in it, like what we would see for a distributive property. So again, just like if I had 5 with a 6 in parentheses, now I have x plus 2 in parentheses. So what that means is 3 times whatever x plus 2 is. We don't know what x is, though. That would be 3 groups of whatever x plus 2 is. It would be, another way to show this is 3 groups of that. You could add it all together, like so. And when you add it all together, this is what's helpful for me. I have an x and an x and an x, so 3 x's, and a 2 and a 2 and a 2, which is 6. So it's 3 groups of x, 3 groups of 2. And so all throughout we have these groups of ways we can represent these expressions. These are called equivalent expressions. They have the same value, and we would use different expressions for different purposes. Now when we're solving an equation, we want to have the most simplified expression so that we can work more efficiently. Okay, so now we're on to the process of the distributive property. So what this is we distribute the outside number to all of the variables, the numbers, all the parts, the chunks, sometimes people call them, they're called terms inside of the parentheses. All right, so it's helpful, you can draw a little line there. Okay, so I have 3 groups of x and 3 groups of a positive 2. 3 groups of an x is 3x. 3 groups of a positive 2, 3 times 2 is 6. Now I can't just write 3x6. I need a sign there. Well, what kind of 6 do I have? Yeah, it's a positive 6. I don't have anything there that tells me that it would be negative, so yeah, it's a positive 6. So let's try another one. This is 4 groups of 2x minus 3, or 4 groups of 2x and 4 groups of negative 3. Well, 4 groups of 2x is 8x. 4 groups of negative 3 is negative 12. What I found teaching this for several years, the process is not the confusing part so much, is remembering what to do with signs. Now remember that if you multiply or divide same signs, so a positive times a positive is a positive, negative times a negative is a positive. If you multiply same signs, you're going to get a positive. If they're different signs, you will get a negative. A positive times a negative is negative. A negative times a positive is a negative. This is different than addition and subtraction of positive and negative numbers. Addition and subtraction of positive and negative numbers, I would encourage you to think of a number line, but this is not at all that. What helps some kids until they get this down solidly is to do this. A negative times a negative is a positive. Positive times a negative is negative. Negative times a positive is negative. So that could help you if you want. Okay. So, see what I mean? This is pretty big. So for each of these rows, each row has a skill in common. And so as we go through each row, I encourage you to watch the first question and then see if you can follow the questions to the right independently. So push pause, see if you can work it out, and then come back to the video and see if you were correct. I'm just going to trust that you're going to do that and keep on talking. Otherwise, this video is going to be a million years long. Okay. So this 4 times the quantity of x plus 1 means 4 groups of x plus 1. 4 times x is 4x. 4 times a positive 1 is positive 4. Good. 3 times x is 3x. 3 times 7 is 21, and that's a positive 21. If you don't need to use the signs, you do not have to use the signs. Now, some people have a hard time determining what number this sign goes to. The sign always precedes the number. The sign always goes before the number that it belongs with. One thing that has helped kids is kind of slang, chunking it up. Consider chunking up expressions that have especially both positive and negative signs. I'll show you that in a couple minutes here. The sign always comes before the variable or the number, and the little chant we say to ourselves is find a sign, draw a line to the left. And again, remember, a negative times a positive will always be a negative product. So it has nothing to do with addition and subtraction. So for example, I'm going to find a sign, draw a line to the left. Find a sign, draw a line to the left. Find a sign, draw a line to the left. All the way through this. If that helps you. If it doesn't help you, don't do it. Right? But it helps us determine what number, what term each sign belongs to. Well, here we have a goofy one where the number that's being distributed is on the right. And that's okay. It's not as common, but it does happen. So 6 times x is 6x. 6 times 8 is 48. Here, 4x and 40. Good. Okay. For these next ones, our x is not singular. Here there's 2 of them. 4 groups of 2 is 8x. 4 groups of a positive 3 is 12. Okay, let's try that as we go through the line. Sorry, I don't know if you hear the train outside my house. 2 groups of 8 is 16. 2 groups of 5 is 10. Going backwards now again. 9 twos is 18. 9 sevens is 63. This is also a lesson where you need to really brush up on your multiplication skills if you don't have those down solid. Let's see, 4 sevens is 28. X. 7 times 1 is a positive 7. All right, now we have some negatives coming in here. This is where remembering your positive negative rules is going to be important. So negative 4 times x is negative 4x. Negative 4 times 1 is negative 4. Negative 7 times x is negative 7x. Negative 7 times positive 1 is negative 7. See if you can do these next ones independently. And hopefully those are your solution. Positive times a positive is a positive. Positive times a negative is a negative. Okay, let's try some others in this next section. Above, we only had positives and maybe 1 negative. Here we have up to 2 negatives throughout. I believe you have what you need to do this next section, but so I would encourage you to do as much of it as you can independently and then push play again, or you can watch and I'll explain as we go here. Okay. Negative 3 times positive 5 is negative 35 x's. Negative times the positive is a negative. Negative 7 times positive 3 is negative 21. Negative 8 times 4 is negative 32. Don't forget the x. Negative 8 times 2 is negative 16. One thing I see sometimes is they're adding together a negative 16. Don't do that. Just write the negative. We don't need both signs. That gets confusing. Okay. Going backwards, this would be 9 times 3 is 27 x's. 9 times negative 2 is negative 18. When you're doing this, I recommend that you go to the variable first. So I didn't write negative 18 plus 27x. The variable comes first, the letter. 7 times 5, 35x. 7 times this negative goes with the 7, so 7 times negative 2 is negative 14. Okay, here we're going to have 2 negatives. Remember, a negative times a negative is a positive. So negative 9 times x is negative 9x. A negative times a negative becomes a positive 36. Negative 8 times x is negative 8x. Negative times a negative is a positive 72. A negative times a negative is a positive 9x. Negative times a positive, negative 18. That gets a little bit squirrely, so again, if it helps you to put these little lines in, you go ahead and do that. I don't really care. Negative times a negative is a positive 8x. A negative times a positive is a negative 24. Okay? So again, a negative times a negative is a positive product. Okay. So we're going to keep on going, just making it a little bit more difficult. We're going to keep a combination of positive and negative numbers, and here instead of a singular x or a negative x, we're going to have larger numbers here. Okay. So negative times a negative is a positive 8x and a positive 32. Good work. All of these were negatives, and when I multiply them with a negative, they become positive. 9 times 2, see, I had skipped over that because a negative times a negative is a positive, so I'm really just thinking 9 times 2 is 18x. Negative times 3 is negative 27. Negative times a negative is a positive. 3 times 7 is 21. Negative times a positive is a negative. 7 times 3 is 21. Negative 6 times 4x is negative 24x. Negative 6 times negative 4 is a positive 24. Good job. Now these are a little bit different. I mentioned it before. If you have a choice, the variable should always come first. If it doesn't, the expression is going to have the right value, but it's not going to be written in the most mature way. And of course, we want you to look like you're educated and you know what you're doing. It's also going to make things a lot easier for you when you're solving equations. So you can do this one of two ways. You can either do the first term, so negative 8 times 2 is negative 16, and then the second term, negative 8 times negative 3 is positive 24x. You can either do that and then flip it around, positive 24x minus 16, because that negative goes with the 24. I'm sorry, the positive goes with the 24. The negative goes with the 16. Or you can just skip to the variable. 6 times negative x is negative 6x. 6 times 7 is 42. And so you could do it that way too. Okay. So again, if you want to do the first bit first, 3 times negative 2 is negative 6. 3 times 3 is 9x. And then flip it around so that the variable comes first. It's a positive 9x and a negative 6. Or again, you could do the variable first. Now that negative goes with the 3. Remember, the sign precedes its value. So this is 2 times negative 3, which is negative 6x, and a positive 12. Okay. Good job. Okay, so this next one is where this gets pretty hairy, where we have a much longer expression with multiple sets of parentheses, and it can get overwhelming, but it doesn't need to be. What I recommend that you do is to focus on parentheses first, and then determine the number to distribute inside. I'm not sure if you can hear. My little boy and my husband are cheering for football in the next room. I'm sorry if you can hear that. Okay, so for this one, we have a set of parentheses, and then what number is connected to that? Yeah, the 2. So this is going to be 2 times the x and 2 times the 4. Here we have another set of parentheses. And this positive 3 goes with this. So it's positive 3 to the x and positive 3 to the 2. So 2x plus 8, I forgot the x, and 3x plus 6. I did them kind of separately. Now I do need to have a sign to separate the two. This is a positive 3x. Now later we will talk about combining like terms, but today we're focusing only on distributive property. So here are my parentheses. Here's the number that's going to be distributed inside. Here's another set of parentheses. Here's the bit that's going to be distributed to the inside. So 3 2's is 6x. 3 6's is negative 18, because a positive times a negative is a negative. Negative 2x and negative 2, like so. And you can just leave it like that. This lesson, soon we're going to change that. Enjoy it today. Okay, here I only have one set of parentheses, but it seems like there's a lot of things surrounding it. What number tells us how many groups of x plus 7 I have? Well, the number that is pushed up against it with no sign in between is the 4, the positive 4. So these other bits, 3 and 7, they just come down. Nothing happens to them. 4 times x is 4x. 4 times 7 is 28. And of course I need to put signs in there to make this make sense. This is a positive 7. See? And this is a positive 4x. So you can try this other one here. This is 8 groups of that. So 8 times negative x is negative 8x. 8 times 5 is 40. And just bring down the other part that's not affected by the distributive property. Okay. Sometimes you will have lots of different terms on the inside of the parentheses. You can have multiple variables, and that's not terribly uncommon. So you're just going to distribute to everything inside the parentheses. So 3 goes to the x and the y and the 5, because this means 3 groups of this expression. So 3 x's is 3x, 3 y's is 3 y's, 3 5's is 15. So it's just what we've been doing, just expanded another step. So 6 times x is 6x, 6 times 3y is 18y, 6 times negative 2 is negative 12. Good. Try these next ones. Push pause, then give it a go. 4x less 8y and 2z's. This one goes backwards. 35x's, 14y's, and 56z's. When these get all jumbled up, when we're talking about combining like terms, we'll bring it up again. It's good to put those in alphabetical order, but for now, that was just a little extra for you. Okay, here we have one more subtle thing that maybe trips kids up. Sometimes when we look at our parentheses, the number that is on the outside isn't a number, it's just a negative. Okay. What that means is that negative is going to be distributed to everything inside of the parentheses, or I'm just going to change the sign of everything that's in the parentheses. That's still confusing for kids. So if it helps you, you can change that negative into a -1. It accomplishes the same thing. So a negative, if I change a positive x to a negative x, becomes that. Change a positive 6 to a negative 6. Okay. So here I'm distributing a negative to everything inside. So negative 7x, negative 2. But that 5x didn't have anything to do with that. So it's just going to go up here. It's going to come straight down. Try the next one. So this is like -1 times negative 2x and times 4. So that becomes a positive 2x and a negative 4. And then that negative 8x again, it's just hanging out in front, not affected by all that negativity. Here we have 2 sets of parentheses. Boy, that makes things complicated. So this negative is going to distribute here. This negative is going to distribute here. So this becomes negative 5x minus 8 and positive x and positive 2, just 2. Okay. And again, in the future, we will be working on combining like terms, but that is where we are going to stop for this lesson. If I did both lessons together, it might make your brains explode, and it's nice to get the prerequisite skill, what you should have learned in 7th grade, in before we start building on that. So you can practice the one bit before we go on to the next. So your homework, if you will notice, was written so that it corresponds with your notes. So your homework has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows. The notes that we did took up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows. So if you are stuck on, say, the 4th row, you can refer to the 4th row, 1, 2, 3, 4, 4th row of your notes, and that should give you examples that you can follow. Okay, that's not the case on the redo side. The redo side is all jumbled up, but I thought for your first go through, I could make that a little bit easier for you. So as you work through these, I want to caution you, please be very careful with your simple multiplication. That tends to be the reason why some kids make mistakes. They know what they're doing, they just goof up their multiplication. Remember, same sign, so a positive times a positive is a positive, negative times a negative is a positive. If you have different signs, you end up with a negative. You can put that up there. And also feel free to find a sign, draw a line to the left, so that you can see what term those signs belong with. Okay? You don't have to, but I encourage you to do that if that would be beneficial to you. All right, as always, if you have questions, please never hesitate to send me an email. I'm happy to help. Here is the address. Happy to help, and of course, I can always talk with you when we're back in school. Thanks a lot, and I'll see you soon. Bye.